Hi everyone, welcome and thanks for joining me today. My name's Kari and I'll be talking to you a little bit about the research that we're doing in Central Australia on the ecology of the Perentie. Thank you to the AHS for this amazing opportunity to be able to share the work that we're doing and a little bit of the adventures that we've had along the way with all of you. A little bit about me and my background. I'm a German Canadian. My parents are German and I was born in Canada and grew up in the US, as you can probably tell from my accent. Most of my childhood was spent around animals. From a very young age, I was absolutely obsessed with animals, whether it was a snake or a frog or a toad or rabbits, hamsters, horses, alpacas, you name it. They were all so fascinating to me. I spent most of my time outdoors with my sister, having adventures in the woods and traveling the world with my family, which I was very lucky to have the opportunity at such a young age to see so much of the natural world around us and really grow an appreciation for what we have here and a passion for wanting to conserve that. After finishing high school in Germany, I moved to Canada where I studied biochemistry and neuroscience at Dalhousie University. After completing this degree, I decided I wanted to follow a career that was more field-based and was more wildlife-oriented. So I studied a Master's of Wild Animal Biology at the Royal Veterinary College in London. Part of this degree was having 2-day practical rotations at London Zoo, which was a really eye-opening and amazing experience. We were able to choose the areas that we were interested in, and I picked the reptile house very early on and ended up just completing all of my rotations there because I fell in love with the animals. And one of the things that I was really lucky to be able to do and watch was the training of the Komodo dragon Gannis. And that really started my love for monitor lizards and fascination by their intelligence and their awareness. And ever since then, being able to research and work with monitor lizards has kind of been the ultimate dream for me. So the adventure continued when I quit my job in Germany and I moved to Australia. I was given the opportunity to volunteer on a research project looking at temperature-dependent sex determination and sex reversal in central bearded dragons, which is a PhD project from Chris Wilde and Phil Pearson. I'm forever grateful to Chris for giving me the opportunity and getting me over to Australia, which was really the big step for me in gaining the experience that I needed and wanted, and also getting me to where I am today. Once we finished the field season with bearded dragons, I actually got really lucky because I saw on Twitter that Simon Clulow was looking for help in Central Australia with a project that was tracking Perenties. So obviously I jumped on the opportunity because that was my dream to work with monitor lizards. And less than a week later, on February 3rd, I was already at Sydney Airport waiting to board a flight. And this was at my gate. Many of you that have been to Sydney probably have seen it, but it was very fitting. And it's just the start of a great adventure. So even on the plane, watching the landscape change as I looked out the window was absolutely amazing. And as I landed, I was given this beautiful view on the drive. We continued the drive and ended up with a view of our very own mountain, Mount Connor, which to me is even more beautiful and has more character. Since then, I've not only been able to capture many Perenties and have adventures in Central Australia with many other herp species such as thorny devils, but I've also been really lucky to be given the opportunity to help out with research on the Daly River, been able to see pignose turtles and both freshy and salties, and I was also able to last year go out and do some reptile and amphibian surveys looking at the effects of cane toads in WA, especially at Elquestro Station in Kimberley. So moving on to our study site, we do our work on Curtin Springs Station, which is a cattle station in southwestern Northern Territory. It's over 1 million acres large, and it's got an annual rainfall of less than 150 millimeters. As I mentioned, we have our own mountain, Mount Connor, which is about 860 meters above sea level and about 320 meters above ground. It's the center of our study site because our animals tend to use areas kind of adjacent and around it. So this is an aerial view of our study site. I've just put a box around it roughly. It encompasses about 350 square kilometers, and as you can see, the mountain is part of the study site. We have an animal that uses it occasionally in the winter, and then you might be able to see there's this rock formation around it, which is used by most of our animals. There's also the Lassiter Highway here. You can see Uluru is about 100 kilometers west, and Alice Springs is about 360 kilometers northeast of our study site. And we've got one road here and one road here that kind of helps us access the places where the animals are. Some of the commonly seen habitats that the animals also use are rocky areas like this one. This is actually the side of Mount Connor. More grassland type areas with a lot of spinifex grass. And then we also have kind of more rocky hillside with few mulga trees and low shrubs, as well as more dense mulga woodland. We've got these unique habitats that are fairly flat and open and characterized by calcrete, lots of subterranean warren systems that were left behind by burrowing bettongs, which are small marsupials that went extinct in the area about 100 years ago. Before I get into the Perentie stuff, I just wanted to show a little bit of appreciation to the other herbs that we have out there. So Central Australia has a really high diversity of lizards and reptiles, and some of them are just absolutely incredible. There are a couple of agamids and geckos that live on the station or around in the surrounding areas, which are always good fun to see. One of my favorite times was being able to see a Woma python. I think they're really cool. And then knob-tailed geckos, because of the facial expression, they're just absolutely great. Definitely not to be underestimated, the flies. They're everywhere and they have no respect. But you learn very quickly that if you don't move and you don't swat at them, they'll settle. And then, like Ben here, you can just walk and be fairly unfazed by them. So moving into the project, our study species is the Perentie varanus giganteus, and it's, as many of you will probably know, Australia's largest lizard. It gets to be over 2 meters in length. It's widely distributed across Australia, across the arid regions, from northern South Australia to Western Queensland, and all the way to the West Coast, including some of the islands on the West Coast. While it's not a species of conservation concern, it is the apex predator in desert Australia, and this means it has great potential to change trophic structure and plays a very important role within the ecosystem. It's traditionally associated with rocky outcrops, and Perenties are known to be exceptional hunters as well as scavenge when provided the opportunity. They have both excellent eyesight and sense of smell, which helps them hunt. The aims of our project are to perform a long-term study looking at different ecological aspects of the species. One thing we want to look at is the spatial ecology of Perenties. So how big are their home ranges? Are they territorial? How do they use their habitat? Are there specific movement patterns that they exhibit on a day-to-day basis, or is it more of a seasonal movement pattern? Are they faithful to their sites? Do they return to the same sites, or do they always use different ones? Then we're also looking at the reproductive ecology. So we want to know, when do these animals breed? What's the breeding behavior like? And then also we want to document and learn about the nesting characteristics. So these are all things that haven't really been documented in the wild. We don't know where females nest. The incubation period for the eggs is around 9 months. And in such a hot and dry environment, the risk of desiccation is very high. So the females must have specific tactics to ensure their offspring's survival. Other things that we're looking at on the side is diet and feeding as well, looking at what the animals eat and whether there are any seasonal behaviors in that, seasonal trends, and then just looking at their general behavior to better understand the species and the role that it plays within the ecosystem. So let's get started with a little video by one of our great volunteers. Isn't that great? It gives me goosebumps every time I watch it. One question that my family and friends ask me a lot is, what do you do all day? And we're doing radio telemetry, so really a lot of what we do is tracking the animals. So we do spend lots of time standing around trying to pick up signals. And that happens on the rocks, in the dunes, on the car, wherever we can get a good vantage point and get a little bit of elevation. There's actually a little bit more to it though, so I'll take you through some of the steps that are involved in our work. So the first step in all of this is finding animals, so detecting them and tracking them, after which then the exciting part of capturing them happens, and then we process the animals and they're implanted with a radio transmitter, which then gets us to the step that we spend most of our time doing, which is radio telemetry, tracking and documenting habitat data. We also use different methods to complement the radio telemetry. Among that is camera traps, as well as behavioral observations and collection of scat. So I'll take you through each individual step and just tell you a little bit about how we do things. The first step really is exciting. It kind of happens by chance. A lot of times you don't expect to find an animal. It's very unusual that you will walk up on one. Most of the time we've been successful in capturing animals, it's been because we found tracks. Either while driving or while hiking towards another animal, we'll see tracks in the sand and then just start following them. So you can imagine that the animals don't always go in the sand, they go into harder ground, and sometimes they go into the rocks, which makes it really challenging to actually follow the tracks all the way up onto the animal. And you do have to kind of get lucky because it's hard to estimate how old the tracks are as well and how far the animal's gone. If we get lucky, sometimes the tracks will lead us to burrows or directly to an animal, at which point we will be able to capture it. We go about capturing animals by lassoing them if they're in the open. Because they're apex predators, Perenties generally don't run from us unless they're already moving and they feel threatened. But if the animals are just slowly walking, particularly the large ones, or if they're hidden under a bush and they feel like they're well camouflaged, they generally will just stay put and watch you instead of trying to bolt. Each case, though, is different. Each capture is different because each animal will react differently. Each animal will be doing something different. And so it's really important to be focused and to watch the animal, see what it's doing, and assess the situation to minimize risk and to really ensure a good and safe capture. This is one of the really fun and rewarding steps. It's always really adrenaline rush when you find that animal and you're able to secure it. The next step is processing the animals. So we weigh the animals and we also do measurements of them. So we look at snout vent length, we look at tail length, we also measure both forelimb and hind limb, and then we take dimensions of the head. If the animal has ectoparasites, most of them do have ticks. We will collect some of them for analysis later. And then after processing, we take the animals to Alice Springs so they can have their transmitters implanted. There's intracellular implants of hollow hill transmitters that have about a 3-year lifespan. So we get a fairly long amount of time to be able to track and follow these animals and learn as much as we can about them. Then we get down to the fun part, the daily routine tracking. So it involves, as you can imagine, lots and lots of walking, looking for signals, driving around and trying to find signal, and then just hiking until we find the animals. That sometimes means walking along the rocks, on the ridges, climbing up the rocks. The animals will go to really cool places, but sometimes that'll be a bit of a challenge to get to them. And once we get them, we record things like temperature, wind speed, GPS location, and then habitat choice. So microhabitat, we take random points just to later look at habitat choice. A lot of animals will also use the dunes for foraging, and we have one particular animal, Eric, who likes to make us do some work and tends to hang out in the winter at the base of the mountain. So it's always a massive hike to go up there and track him, make sure he's still there and doing okay. Another thing I wanted to share with you is how good Perenties are at camouflaging. So sometimes it's hard to believe us when we say that we almost stepped on an animal that's nearly 2 meters long. But this actually does happen just because they're so good at hiding. I'll show you some examples. This is an easy one. This is one of our females. She's basically in the open, lying on leaf litter. And although the spots are so obvious against a red background like sand, if you look at this, you can see how well they already blend in. Here's another one, trying to spot Brutus. He's 1.75 meters. I'll zoom in. So he's hiding under this dead branch. And this just kind of highlights the difficulty we have in actually locating the animals, even when we're directly in front of them. Sometimes it's a challenge to locate them. This is another view of him from the side. So sometimes walking around helps because from a different angle, you can see them more easily. As I said, we also use camera traps to complement the tracking, which helps us learn more valuable things about these animals. So we position the cameras in front of dens and warrens that some of the animals will use, and that teaches us when they come out and what type of activity patterns they have. And sometimes we also get lucky, like with these two, and we get to see feeding behavior. So this one here is Jamie Lee, one of our animals, who's caught a little agamid. And then this was just actually a random find of one of the cameras we had set up. So it's really cool to be able to witness more behavior without actually being there. Obviously, with the camera traps, we also get some surprise visitors. So we get different birds, fairy wren. This is a little hopping mouse. And then we get dingoes pretty frequently. Here we've got one and a rabbit dashing into its little hole into safety, which was a pretty cool capture to get when you pick up the cameras and then later on you see what you've captured. It wasn't a Perentie, but it was still cool. Then, as I mentioned, we also do behavioral observations. This is one of our males. Really cool to see. The cows don't even realize he's there because he's just not moving. Quietly observing it. Some other cool behaviors that we've picked up on while tracking are this one, which generally we see when the animals are still out and it's pretty hot out. Pretty impressive. And then also something that we've seen in the heat of the day. Animals digging. So that's one of the best things I think about tracking is being able to find the animal and then watch what it's doing and see some of its behaviors when it's out. It's really rewarding. One of the other behaviors that we picked up on while tracking is arboreal behavior. So the Perenties that we track actually spend a significant amount of time in trees, which wasn't really documented before. A lot of times early in the morning or really late at night after sun has set, we'll find animals in trees. And it's not just the little animals, it's also big animals occasionally that will do this. We haven't really figured out yet why exactly it is, whether it's an anti-predatory mechanism or whether it's more of a get the first rays of light for basking type thing. But it's always really cool to be tracking an animal and then realize it's above your head watching you. So now I'll just go into some of the results that we found. Obviously the study is still going on and we have a lot more things ahead of us, but we've been able to make some cool conclusions already. This is our study site, and these are all of the locations that we've documented for our animals. So at the moment we're tracking 17 individuals. They vary in snout vent length from 51 to 82.5 centimeters, and also total length of 1.22 to 1.89 meters, as well as there's a pretty large discrepancy in weight from 1.4 to 6.2 kilograms. And here you can also see that there's a pretty big difference between some of the animals and how much they move. Just a quick overview of body size and weight. You can see here, these are the big males. The snout vent length, as you would expect, increases, or weight increases with snout vent length. Down here, you can see there's quite a lot of ewes, unknowns, and then a few females, which is a result of the fact that we have a really hard time actually sexing the smaller animals. So with big animals, when we capture them, a lot of times the males will evert their hemipenes, like so. So this is really helpful for us because it means that we're able to more easily identify the sex of the animal. Radiographs also help us with this because the bigger males, the mature males, will have calcified hemipenes, which will show up on the radiographs. It's the smaller ones that are really hard to sex because it's difficult to differentiate between the small males and the females. So that's one thing that we're looking at, perhaps doing more genetics to be able to confirm the sex of the animals. Other really cool things that we can learn from the radiographs are we learn a bit about feeding. So you can see here, there's a blue tongue in here, as well as varanid. Here's the head, if you can see it. So we can learn about what the animals eat. We've got snakes in both of these stomachs. But we can also see other things about the animals that you wouldn't be able to see from the outside. So this male here actually fractured both its front and hind right limb at some point in time, but you can see that both fractures have completely regrown even if they're not straight. And it's actually really cool then knowing that to see how well this animal has adapted and how healthy it is despite the slightly crooked legs. So this male actually has a pretty large home range and he's perfectly healthy. Another cool and surprising finding that we had was this year when we captured Vlad. We realized that he had this branch, this mulga branch sticking out of his side. So when we went into surgery, the vet removed the branch and it ended up being way longer than I think any of us expected. And it was absolutely fascinating to see that this animal that, you can see the hole here, had such a massive stick stuck inside it, was able to survive and be absolutely healthy. You can see that the skin just kind of grew around it. So these are unusual observations and findings that we get to make, which are always really cool and rewarding. Moving on to the results, we definitely can see that there's a difference between sexes in the size of home range. So we have a female here who has a home range of less than 1 square kilometer. She basically never really left the rocks in all the times that we tracked her. And then in comparison, we've got a male here, a fairly large male. He's about 1.70 meters long and 4 kilograms heavy. He roams a lot. He really likes going out into the dunes and foraging there as well. And that's really visible here. He's got a much larger home range of almost 14 square kilometers. So this difference is also mirrored by the behaviors that we see in the animals. To show that, we've got a release video here of one of our smaller animals, Mac. And this is really characteristic of the smaller animals. They'll just, as soon as you let them go, they'll run away and they'll dash. A lot of times when you're tracking them, you'll realize that the animals started running because it's realized that you're coming. And in contrast, the bigger animals are a lot bolder. They don't really care. They're not really fazed by you. This is just an animal that I happen to walk past. And you can see he knows I'm there, but he doesn't really feel threatened. He just kind of continues about his own business, strutting along. All right, so looking at all of the home ranges together, this is a 95% kernel density estimate. You can see that the males, which are the triangles, tend to have much, much bigger home ranges. This one is Eric. He's got the biggest home range. He's the animal that I mentioned also uses the mountain. So these are the points that we have on the mountain. And he spends the winter there and then walks all the way down here and spends the warmer season all the way over here. You can see then the smaller ones, the females like these here and Helen here, the one that I just showed you, are really, really small in comparison. But you can also see that a lot of these males' territories overlap. So it seems that at least for most of the year, they're happy to share the same areas because I think they don't really share the exact same area at the same time. It's a pretty large range, so you can avoid other animals. And one other thing that's really interesting is that since we've been tracking for 2 seasons, we can see that the animals really have their core range. They don't vary from season to season, but they actually stay in the same area year after year. So it'll be interesting to see what next year looks like. All right, so last I want to touch on nesting, which we made some major breakthroughs last season. We were able to capture a gravid female in November, which was absolutely exciting. When we took her to the vet, we put her under the X-ray machine and this image popped up. You can see the eggs here, here, here. And this was really the major first step to understanding and learning more about the nesting characteristics and behaviors of the species. So after we released her, we watched her and we tracked her. She ended up going into a burrowing bettong warren where she stayed for weeks. I went out every day and sat a ways away observing the warren. We put up camera traps on the entrances and I regularly tracked her within the system to make sure that she was still there and see whereabouts she was. Finally, after several weeks, she resurfaced. When I tracked her early in the morning, I found her in a nearby tree looking absolutely exhausted. And that was a really special moment because at that point, I knew this is the first documentation of a female Perentie laying eggs. Our camera traps picked up the same female multiple times after she laid, going back in and out of her warren. Another really interesting thing was that we discovered that there was a male this whole time that I observed her and I was sitting on the warren watching. There was a male that was watching me. So it was always the same male and he was around for several weeks as well. This is him poking his head out of the entrance of the warren and doing what I would presume is guarding the nest. Here's another camera trap image of him just sitting out front. This is actually the main entrance to the warren that she nested in. So this is another really cool new observation that will be interesting to see if we're able to see it again next year and start to learn more about how common this is and what it means. And this is also the female the day after she laid, just watching me sticking her head out of the entrance of that warren where she nested, which is really cool. So that kind of also raises the question, what role do these warrens play for the females? So in the future and in the next season, we're looking to document more nests, more nesting events, and learn more about the characteristics of these nests to understand the properties and the reasons behind the females nesting the way they do. We also obviously want to look at bettong warrens more closely and see what role they play for the Perentie. So are these warrens the key for their survival in Central Australia because they provide the perfect incubation habitat for their eggs? We don't know, but that's one thing that we want to look into. Then, as I already touched upon, we're going to be looking at sexing the animals using genetics, and karyotyping, then also performing dietary analysis, understanding how and what these animals feed on, and then also looking at interspecies interactions. So how do these animals interact with other predators, introduced predators like dingoes and cats and foxes. So that'll be really interesting to get a better understanding of the role that the Perentie plays within its environment. Last thing is, one big limitation of our study is that at the moment, because we're limited to VHF radiotelemetry, we can only track as much as we physically can handle. And with the high amounts of movement of these animals, it's really challenging to stay on top of 17 animals at once when you're tracking on foot. So next season, we're introducing GPS loggers and accelerometers, which will be really cool and really exciting, because it means that we'll be able to gather much more spatial information, and that will enable us to analyze more closely the movements of these animals and also better understand their habitat usage. You can see we've done a lot of work already, and there's way more work set out for us, and it'll be really exciting to see where this goes and the things that we learn in the coming seasons. And that leads me to saying thank you. Thank you first off to my supervisors, Simon Clulo, Martin Whiting, and Sean Duty, for all of their expertise, insight, humor that has kept me going along the way. Thank you to the research team, Dave, Cody, Brett, Ben, and Chris. You are the ones that made this project possible and kept it running on the ground. And we wouldn't be doing this work with so many animals if it wasn't for you, so thank you. We also greatly appreciate the funding that has made this project and the research possible from Jane Fenwick Foundation, Macquarie, USF St. Pete, and Tennessee Tech. We've also received immense support from Curtin Springs and the Severn family that runs the station. It's been really rewarding to be able to share the things that we find with the family and all of the visitors on the station. It's always nice to be able to not just experience things, but share the experience with others and teach others about what you're finding. Thank you so much for your support. Thank you also to Alice Springs Vet Center for helping us out with all of the surgeries. You've done an excellent job, and we're so grateful for your work. Also, thank you to Northern Territory Parks and Wildlife for helping us out with the camera trap study that we've set up to look at interspecies interactions. Lastly, the biggest thanks of all goes to our amazing and talented volunteers. Especially in the past season, we had a lot of different people from different backgrounds all around the world come out and help us track these animals just because they were interested and they wanted to learn. So thank you all for helping us out. Your support means the world, and I'm very grateful that you all came out and put so much hard work and time into this project. It's really made a massive difference. So without further ado, thank you for your attention. If you have any questions or you have any comments, feel free to get in contact with me. You can find me on social media, or you can send me an email. I really look forward to hearing from you, and I hope you enjoyed my presentation. Enjoy the rest of your day or evening. Thank you.